Behold, the terminal, a canvas as monochrome as a noir film. It is, shall we say, lacking a certain panache. Do you crave a dash of graphical elegance? If so, Tkinter is your paintbrush and Python your canvas. Are you ready to summon your inner Leonardo? Well, are you? Graphical interfaces. The difference between merely functional code and something that feels alive. Tkinter is Python's native toolkit for adding that spark. Let us create the smallest possible Tkinter application. First, import Tkinter with the standard alias tk. Call the tk constructor to create a window. This will be the root window in our widget tree. Finally, call main loop to keep our window active. Observe. A window materializes, but it lacks artistic inspiration. The default title tk is literally literal. The dimensions appear to have been randomly generated, most unsatisfactory. Let us enhance this window with some basic parameters. Use the title method to provide a custom window title. Use the geometry method to specify the size for the root panel. Execute once more. Better. A window of proper proportions with a proper title. Other than the complete lack of widgets, it is good to go. Time to populate our interface with basic elements. Begin with a label widget to display text. The first argument is the parent container, our root window. The text parameter specifies what to display. But creating is not enough. All widgets must be told where to exist in the window. Use the pack method to position the label. Execute. I see text people. Next, create an entry widget for text input. Once more, you need to specify the parent widget. And do not forget to pack the widget to the window. Thirdly, we create a button widget. Like the label, it requires a parent and text. But buttons can be clicked. The command parameter specifies which function to execute. Define a function called processData. For now, it will simply print to the console. Pack it below the label. Run. Observe how the widgets are stacked vertically. The pack method is just one way to arrange widgets. Let us see another more familiar method, the grid. Like an HTML table, grid organizes widgets into rows and columns. For our demonstration, we will create a login form, one that does everything except actually log you in. Begin with a label widget for the username. The grid method requires two parameters. Row 0 and column 0 marks the top left position. Next, we need an entry field for the username input. Place it in row 0, column 1. Now for the password field. Another label in row 1, column 0. Another entry field in row 1, column 1. For the password field, set the show parameter to asterisk. This masks the input. Very secure. Finally, add a login button. Use column span equals 2 to make it span both columns. Execute. Observe the precise alignment. Each widget sits in its assigned cell, like a spreadsheet for your interface. But the widgets appear rather cramped. We can do something about this. The pad X parameter adds horizontal breathing room, while pad Y adds vertical spacing. Update each grid call with padding parameters. Execute once more. Roomy. Grid layout. Precise, predictable, preferred. Time for a quick break. And a word from our sponsor. Just kidding. We do not have sponsors. What we do have are patrons. And that is something far, far superior. Our patrons on Patreon love what we do and we love them back. To join this special group of special human beings, visit patreon.com/Socratica. Break over. Our login form looks lovely, except it does not log you in. It fails to react when you click the button. A rather serious design flaw for a button. Let us remedy this oversight. First, define a function called checkLogin. This function will execute when the button is clicked. Inside the function, we use get to read the entry fields that contain the username and password. Print the username to the console. For the password, we have only allowed asterisks to be printed. Security protocols must be maintained at all times. Now connect this function to the button. The command parameter tells the button what to do when clicked. Set it to our checkLogin function. Execute. Enter some test data. Click the login button. Credentials appear in the console. But what if our user has clickophobia? Do you have clickophobia? As an alternative, let us add keyboard control. The bind method connects events to widgets. We will use bind to the username field to listen for the return key. When pressed, the focus will move to the password field. Let us also add bind to the password field. When return is pressed here, the login will be triggered. Run once more. Now our form responds to both mouse and keyboard, just like a proper login system, except for the actual login part. That would be a security risk, even in a video. Is our form complete? No. Right now, the username and password are retrieved from their entry widgets. A better approach would be to connect data variables to the widgets. Enter Tkinter's variable classes: StringVar for text, IntVar for whole numbers, doubleVar for decimal numbers, and BooleanVar for true-false values. For our login form, we will use StringVar. Create one StringVar for the username field. Create another for the password. You connect these variables to their entry widgets with a text variable parameter. This establishes two-way binding between the variable and the widget. When the variable changes, the widget updates. When the widget changes, the variable updates. Perfect synchronization. To demonstrate, let us modify our checkLogin function. Instead of calling get on the entry widgets, we call get on our variables. Run. The result is the same, but our code is more elegant and more flexible. Prepare to observe the synchronicity. Create a label that displays the username. Connect it to the username variable with a text variable parameter, and add it to our grid. Update. Now when we type in the username field, the label updates in real time. Time to explore some additional widgets. For demonstration purposes, we will create a landing permit application. For Mars, first, observe the interface mockup, a drop-down for selecting landing sites, radio buttons for stating your purpose, a text area for detailed input, and checkboxes for required declarations. Let us build this glorious interface step by step. Create a function to handle form submission. It will print the values from each form field. We will use Tkinter variables to store these values. Create the root window, set an appropriate title, and use the geometry method to give it a reasonable size. Next, declare our variables: StringVar for the landing site selection, IntVar for the purpose radio buttons, and two BooleanVar objects for our checkboxes. Now for the landing site section. Create a label. Grid it at row 0, column 0. Create a list of landing sites. The combo box widget displays this list. Connect it to our StringVar. Set a default message. For visit purpose, create another label. Create tuples of text and values for our radio buttons. Use a loop to create and position the radio button widgets. The experience section needs a label and a text widget for multi-line input. 4 rows should suffice. Add a label for required declarations. Create 2 check button widgets, one for iron oxide allergies, another for Mars time acceptance. Finally, add a submit button. Launch. A complete landing permit application. Each widget is nicely positioned, each serving its specific purpose. Your application for Mars landing clearance may now proceed, subject to approval by Mars Surface Control. Et voilà! Your first foray into GUI creation. A world where buttons, sliders, and text boxes are your obedient minions, ready to respond to your every whim. But do not stop here. Tkinter is a gateway, not a destination. Experiment, iterate, and build interfaces that are as clever as your code.